Assalamu alaikum, it's me Mutaira from Electrical Department, Quest Campus, Ladkana. My roll number is L20EL05, subject Advanced Electrical Machine, presentation assigned by Said Qurban Ali Shah. Question number 1, is the turn ratio of a transformer the same as the ratio of voltages across the transformer Y or Y not? Answer: yes, it is essentially true. It is observed that ratio of voltages of transformer are same as ratio of their turns because flux linking both the coil is the same, so voltage will be directly proportional to the number of turns. Formula is given below. Question number 2. Why does the magnetization current impose an upper limit on the voltage applied to a transformer core? When higher voltage is applied, the core saturates and the magnetization current rises to produce an ohmic voltage drop in the coil wiring, which will eventually burn out. Question number 3. What components compose the excitation current of a transformer? How are they modeled in the transformer's equivalent circuit? Answer: the exciting current has two components: the core loss current, the magnetizing current. The core loss is a real power component due to hysteresis and eddy current revealed as heat generated in the core. Now question number 4. What is the leakage flux in a transformer? Why is it modeled in a transformer equivalent circuit as an inductor? Flux extends from the pole side. This flux is not doing anything other than wasting energy. Therefore, leakage flux. It is modeled as an inductor because it is inductance. This is the diagram. Now question number 5. List and describe the types of losses that occur in a transformer. Answer: resistive. Resistive loss or I2R loss or copper loss is the power loss in a transformer caused by the resistance of the copper wire used to make the winding. Eddy current loss. Eddy current loss is power loss in a transformer or motor due to current induced in a metal parts of the system from the changing magnetic field. Hysteresis loss. Hysteresis loss is loss caused by the magnetism that remain lags in a material after the magnetizing force has been removed. Question number 6. Why does the power factor of a load affect the voltage regulation of a transformer? The lagging power factor demand more current and it cause more voltage drop in transformer winding. The load power factor also affect the transformer voltage regulation. Moving to the question number 7. Why does the short circuit test essentially show only I2R losses and not excitation losses in a transformer? Short circuit test only show I2R loss because with the low voltage there is minimal loss in excitation. This small loss is because the magnetic flux being very small. Minimal, it means small. Question number 8. Why does the open circuit test essentially show only excitation loss and not I2R losses? Since the no load current is very small, it doesn't contribute to the copper loss. There is no load on the secondary side. Question number 9. How does the per unit system of measurement eliminate the problem of different voltage level in a power system? Per unit system provides the value of voltage, current, power, impedance and admittance. The per unit system also make the calculation easier as all the values are taken in the same unit. This is how we calculate per unit system measurement. Why can auto transformer handle more power than conventional transformer of the same size? The leakage flux and the resistance of an auto transformer are low because it has only one winding, whereas it is high in conventional transformer. The auto transformer is more efficient as compared to the conventional transformer. What are transformer taps? Why are they used? Transformer taps allow the coil ratio and therefore voltage ratio to be changed. This is used to adjust the voltage, output voltage if the input voltage differs from the nominal voltage. Why are the problems associated with the YY or star star three-phase transformer connection? If the neutral connection is not provided and an unbalanced load is connected, then the phase voltage tends to become several unbalanced. Thus, the star to star connection is not satisfactory for the unbalanced loading in the absence of a neutral connection. What is TCUL transformer? The TCUL transformer, also called tap change under load transformer, is a transformer that has multiple taps, each at a different turns ratio, allowing for changing the voltage reduction from the voltage on the primary side, also called load tap changing LTC transformer. Question number 14. How can three-phase transformation be accomplished using only two transformers? What type of connections can be used? What are their advantages and disadvantages? Answer: there is a technique to do three-phase transformation with the use of two transformers. The easiest way to transform three-phase voltage into two-phase voltage is with two conventional single-phase transformer. The first transformer is connected phase to neutral on the primary three-phase side, and the secondary transformer is connected between the other two phases on the primary side. Four three-phase transformer connections are there, which are Y-Y connection, Y-delta connection, delta to Y connection, and delta to delta connection. Advantages: inexpensive. It means not expensive like other connections. Lightweight, assembly in the least time, higher efficiency, easier to install, easy transportation. The more disadvantages: the more significant cost of standby units, cost of repair, reduced capacity, fault corrections. Now moving to the question number 15. Explain why the open delta transformer connection is limited to supplying 57.7% of a normal delta to delta transformer bank's load. Voltage unbalance is less with lower impedance transformer. This is the reason that the power output from the open delta transformer is 57.7%. Can a 60 Hz transformer be operated on a 50 Hz system? No. What actions are necessary to enable this operation? These type of operations we can do. If a 60 Hz transformation is to be operated on 50 Hz, its applied voltage must also be reduced by 1/6 of the peak flux in the core will be too high. Question number 17. What happens to a transformer when it is first connected to a power line? Can anything be done to mitigate this problem? It becomes a coil and an electromagnet. This can be overcome by using zero cross relays to power it on and off. What is potential transformer? How is it used? A potential transformer is an instrument transformer which is used for protection and measurement purpose in the power system. It is mainly used to measure high alternating voltage in a power system. Question number 19. What is current transformer? How it is used? A current transformer, CT, is a device that is used to measure the current of another circuit. Current transformers are used worldwide to monitor high voltage lines across national power grid. Question number 20. A distribution transformer is related at 18 kVA, 20,000 480 voltage and 60 Hz. Can this transformer safely supply 15 kVA to a 415 voltage load at 50 Hz? Why or why not? Answer: there are three factors that affect this. Unless the transformer has adjustable taps on the winding, you will need a 17,292 volt input for a 415 volt output. The saturation of the core may be a factor at a lower frequency. If the transformer relies on tape changes to get the correct ratio of input to output, you have to be aware of the different voltage to current ratio involved with operating using different tap settings. At the particular out voltages, you specify the current at 415 volt is slightly lower, so it will probably not cause excess heating of the windings. Last but not the least, why, question number 21, why does one hear a hum when standing near a large power transformer? We can hear an audible hum in a transformer because electric currents affect its internal structure and cause vibration. Thank you.